It's pleasure to introduce myself to you. This is B. Indramanikantan, studying in ECA section, bearing roll number 23BQ1A0426. Today I am here to tell about the elements of the communication system or the components of the communication system. Next, modulation and demodulation. First, come to the communication system. Majorly, it have first source of information, next transmitter, next through it pass through channels, and then receiver, and then its final destination. First, what is meant by source of information? The information source contains message signal to be transmitted. The two main source of information are ideas emitting from human beings, changes in the physical environment. The signal is also called as message signal. It is measured in the bits. Next, what is meant by transmitter? It is a collection of electronic circuit designed the information into a signal suitable for transmission or a given communication medium. Some message signals that comes from information source are non-electrical and it is not suitable for transmission, or non-electrical transmit that signal. It should be converted into electrical signals, which will be done by transducers. Next first we completed so source of information. Next, go to input transducers, a device that converts the source information into an electrical signal. Example, microphone, keyboard, camera, sensor. Its function: transforms non-electrical information into an electrical signal that can be processed and transmitted. Next, third one, transmitter, a device that process and sends the electrical signal to the communication channel. Example, AM or FM radios, transmitters, modems, and etc. Its function: signal processing, in which it includes modulation, amplification, and encoding. Modulation converts the message signal into a form suitable for the transmission medium. Fourth one, channel with noise added, the medium through which the signal travels from the transistor to the receiver. Example, wired channel, copper cable, optical fibers, wireless channel, radio waves, and satellite links. Function: carries the signal between transmitter and receiver, but it is prone to interference and noise, unwanted disturbances that degrade the quality of the transmitted signal. Next, fifth part is receiver. A receiver that receives the transmitted signal, extracts the information, and reconstructs the message. Example, radios, TVs, and mobile phones. Next, function of the receiver: demodulation, converts the modulated signal into its original form. The original form of any signal is message signal. Next, amplification, boosts the received signal strength. Decoding, interprets the encoded information. Sixth part is output transducer, a device that converts the received electrical signal back into its original form. Example, loudspeakers, display screens, printers, etc. Function: reconstructs the message into a format understandable by the humans or other systems. Destination: the endpoint or target where the message is intended to reach. Example, a listener in a phone call, a viewer of a television of broadcast, a computer in a network. The function of destination or the final output parties: receives the final output of the communication systems and interprets or uses the message. Next, what is meant by the modulation? It is a process of changing some characteristics like amplitude, frequency, phase of a carrier wave in accordance with the instantaneous value of the modulating signal. It enables the efficient transmission of information over any distances and through various media. Key elements in modulation: Carrier signal, a high frequency signal used as a base for modulation. Message signal, the information or data to be transmitted, also called as the modulating signal. Next, modulated signal, the resulting signal after modulation which carries the information. And what is meant by demodulation? It is the process of extracting the original message signal or information from the modulated carrier signal. It is the reverse of modulation and is performed at the received end to retrieve the transmitted data for processing or interpretation. Key elements in demodulation. First one is demodulated signal, the received signal containing the carrier and the embedded message. Next, demodulator, a circuit a circuit or a device that receives the original message signal from the modulated signal. And what are the types of modulation? Modulation is basically of two types. One is continuous wave modulation and second one is pulse modulation. In continuous wave modulation there are two types. One is linear modulation and second one is angle modulation. Whereas in phase modulation is also contained two types: digital modulation, analog modulation. And where in continuous wave modulation and in that linear modulation there are again four types: amplitude modulation, double sideband suppressor carrier and single sideband suppressor carrier. Next, vestige sideband. In angle modulation two types: frequency modulation, phase modulation. Next, what are the needs of the modulation or advantages of modulation? First, it reduces the height of antenna, avoid mixing of signals, increase the range of communication, allows multiplexing of signals, allows adjustments or changes in the bandwidth. And sixth one is improves the quality of reception. First, we detailedly know the needs of the modulation. First, avoid mixing of signals. Without modulation, multiple baseband signals would occupy the same frequency range. This can lead to the interference and signal overlap. Modulation assigns direct frequency bands to each signal and ensuring that signals do not mix or interface with one another during the transmission. Next, increase the range of communication. Low frequency baseband signals cannot travel the longer distances to due to significant attenuation and energy loss. Modulation transfers the signal to a higher frequency range, example radio waves, which can travel longer distances with less attenuation. This extends the communication range. And next, allows adjustment in bandwidth. Modulation helps control the bandwidth of the signal to match the channel capacity. For example, high frequency carrier can support large bandwidth, allowing more data to be transmitted efficiently without signal distortion or loss. Next, improves the quality of reception. High frequency signals are less affected by the noise, interference and other distortions during transmission compared low frequency signals. By modulating signal onto a high frequency carrier, the quality of reception is significantly improved, ensuring better clarity and reliability of communication. Next, reduces the height of antenna. For efficient transmission of signals, the height of antenna should be proportional to the wavelength of the signal. Baseband signal, which are low frequency signals, are having large wavelengths, require extremely tall antennas for transmission, which is impractical. Modulation shifts the signal to a higher frequency, reducing the required wavelength and consequently the antenna height. This makes the system more flexible. And next we go to multiplexing. And multiplexing is a process of combining multiple signals into one signal over a shared medium. If the analog signal are multiplex, then it is called as analog multiplexing. Similarly, if the digital signals are multiplexed, then it is called as digital multiplexing. The number of signals were combined to send through a single cable. The process of multiplexing divides a communication channel into a several number of logic channels, allotting each one for a different message signal or a data stream to be transferred. The device that does multiplexing can be also called as multiplexer or mux, where the opposite of the mux is demux. And next, the reverse process in extracting the number of channels from one, which is done at the receiver, is also called as demultiplexing or demux. The device that does demultiplexing can be also called as demultiplexer or demux. And the next types of multiplexes. Multiplexes are of two types. First one is analog and digital. In analog, again two types: frequency division multiplexing, wavelength division multiplexing. In digital, it based on time division multiplexing, and it of two types: synchronous time division multiplexing, asynchronous time division multiplexing. In frequency division multiplexing, the total channel bandwidth available to the system is divided into smaller non-overlapping frequency bands, which are also called as subbands, which enables the receiver to separate them and recover the individual messages. The block diagram of a typical frequency multiplexing system is shown in the figure. And here we consider three message signals: M1 of t, M2 of t, and M3 of t. The lower pass filter, a transmitter section of a frequency multiplexer system, removes high frequency components of a message signal and disturbs the other message signal that shares the channel. These filter signals modulate the carrier, having the frequencies fc1, fc2, and fc3 respectively, so that the resulting modulates waves do not overlap, do not having overlapping spectra. The band pass filters after the modulators are used to restrict the band of each modulated wave to precise range. All the signals are now combined to produce composite signal S of t, which is then transmitted over the channel. If the receiver and suitable bandpass filters tuned to the carrier frequencies are then employed to recover each of the modulated carriers carrying the individual signals. Each modulated signal is again passed through a demodulator to get back the original message. In an FDM system, the bandwidth allocated to each subband is slightly large than the bandwidth needed to the each message. The extra bandwidth is also called as guard band. Next, channel bandwidth of frequency multiplexing. If n message signals each having bandwidth equal to W edges, then the minimum bandwidth of the channel should be greater than the NW edges. Channel bandwidth of frequency is so much greater than or equal to NW edges, where n indicates the number of messages to the multiplexer. Next, applications used in the telephone systems, telemetry, and commercial broadcast, and in communication network. Commercial FDM broadcasting stations was frequency band. The commercial frequency range of a broadcasting solutions were 80 MHz to 108 MHz. Thank you for giving this golden opportunity. Have a good day.